again, to see where this equation comes from, let's look at the graph. If we have clock time t0 and then the time changes by t dub to t0 plus t dub, our quantities are going to be q of t0 here and q of t0 plus t dub here. If this is the doubling time, then this quantity is double this quantity. If this quantity is double this quantity, then we have q0 b to the t0 plus t dub, which is q of t0 plus t dub, equals double this quantity, double q0 b to the t0. So this is the condition for doubling time at time t0 at least. Let's see if we can get this straight. Camera angle's a little bit problematic here. Okay? So here's our condition for doubling time at time t0. Now, this is an equation that can be solved for t dub. All we have to do to solve it, we've got q0 on both sides, so we'll multiply by the reciprocal of q0. We get b to the t0 plus t dub equals 2b to the t0, just essentially removing the q0 from both sides. Then what do? Well, law of exponents says that b to the t0 plus t dub is b to the t0 times b to the t dub. That's one of your basic laws of exponents. A to the bc equals a to the b times a to the c, or whatever. It can be stated in terms of a lot of different letters. Let's try to get our orientation straight here. Okay. So we rewrite b to the t0 plus t dub as b to the t0 times b to the t dub. And then of course we see that we have a b to the t0 common to both sides. We multiply by the reciprocal of b to the t0 and we get b to the t dub equals 2. Now we can't really solve this equation except by trial and error. If we know the value of b, we can put different times t in here until we get a result that looks like 2. So if we know b, we can use trial and error to get an approximate solution to this equation. To get the exact solution, we're going to need to use logarithms, which we haven't studied yet. One of the main things we want to look at here is that t0 doesn't appear in this equation. Since t0 doesn't appear, t0's not going to appear in the solution. So when we get t dub, it's not going to depend on t0 at all. It's only going to depend on b. So the doubling time is strictly a function of our growth factor b. Remember, b is our growth factor. So the statement here says t0 doesn't appear here, so t dub's always the same for given b. Very important idea and a very important property of exponential functions.